The Soviets were not planning to build a space shuttle. In the early 70s, they were watching the American Space Shuttle program. A strange design, they said, expensive, inefficient. A reusable spacecraft did not make sense. But then they started to worry. CIA reports suggested the shuttle would be used for military purposes. It could capture Soviet satellites from orbit. It could carry nuclear weapons. It could make a sudden dive over Moscow. The KGB went into action. They launched one of the largest technology theft operations in history. Hundreds of agents were mobilized. Documents were stolen from American aerospace companies. NASA employees were targeted. Computer systems were infiltrated. The result? The shuttle's design plans, test data, and engineering solutions flowed to Moscow. Soviet engineers began working with this information, and they built an almost exact copy of the American shuttle. Buran was the product of history's most successful industrial espionage operation. This is the story of how the Soviet Union stole America's space shuttle, how they copied every detail, then improved upon the original, and how the spacecraft that flew only once became a symbol of Cold War ambition and Cold War collapse. To understand why the Soviets stole the shuttle, you must first understand what the shuttle was. The Space Shuttle program began in the late 1960s. NASA wanted a reusable spacecraft that could reduce the cost of access to space. Instead of throwing away rockets after each mission, the shuttle would return to Earth and fly again. The design was revolutionary, a winged orbiter that launched like a rocket but landed like an airplane. 2 solid rocket boosters that could be recovered and reused. An external fuel tank that was the only expendable component. The shuttle could carry astronauts and cargo to orbit. It could deploy satellites, service the Hubble Space Telescope, and build the International Space Station. It was supposed to be the workhorse of American space exploration. The first shuttle, Columbia, flew on April 12, 1981. The mission was a success. America had a reusable spacecraft. Soviet leadership watched with growing concern. The shuttle was not just a scientific achievement, it was a potential weapon. The Soviet military saw threats that American civilians did not. The shuttle's cargo bay was enormous. It could carry 29,000 kilograms to orbit. That was enough for multiple nuclear warheads, or sophisticated anti-satellite weapons, or reconnaissance equipment that could photograph Soviet installations from space. The shuttle's maneuverability was concerning. Unlike a ballistic capsule, the shuttle could change its re-entry trajectory. It could approach Moscow from unexpected angles. Soviet air defenses might not be able to track it, and the shuttle could capture satellites. Its robotic arm could grab objects in orbit and bring them into the cargo bay. Soviet military satellites could be snatched from space and examined. Most worrying was the shuttle's potential for bombing. Some Soviet analysts believed the shuttle could dive from orbit, release nuclear weapons over Moscow, then climb back to space before defenses could respond. These fears may have been exaggerated. The shuttle was never designed as a weapon. But Soviet military planners had to assume the worst, and the worst was terrifying. The Politburo made a decision. The Soviet Union would build its own space shuttle, not for exploration, for defense. The KGB received its orders. Obtain everything about the American space shuttle. What followed was one of the most extensive espionage operations of the Cold War. The KGB's Scientific and Technical Intelligence Directorate, known as Directorate T, coordinated the effort. Hundreds of agents and assets were involved. The targets were everywhere. Rockwell International, the prime contractor for the shuttle orbiter. Morton Thiokol, which built the solid rocket boosters. Martin Marietta, which manufactured the external tank. Thousands of subcontractors across America. The methods were diverse. Some documents were stolen outright by agents with access to aerospace facilities. Others were obtained through front companies that purchased technical publications and research papers. Some came from scientists at academic conferences who did not realize they were talking to Soviet intelligence. Computer systems were infiltrated. Technical databases were copied. Even trash was searched for discarded documents and drafts. The operation was remarkably successful. By the late 70s, Soviet engineers had access to extensive documentation about the shuttle's design. Aerodynamic calculations, thermal protection specifications, flight control software architecture. They did not have everything. Some critical details remained secret, but they had enough to build their own version. Soviet engineers faced a choice. They could design an original spacecraft based on their own concepts. This would take longer, but would result in a vehicle optimized for Soviet needs and manufacturing capabilities. Or they could copy the American design. This would be faster and would ensure they matched American capabilities. But it would mean building a spacecraft designed for American technology and American requirements. The debate was intense. Some engineers argued for an original design. The shuttle's configuration was optimized for American specifications. A Soviet-designed vehicle could be better suited to Soviet purposes. But time pressure won. The Politburo wanted a response to the American shuttle as quickly as possible. Copying the proven design would reduce development risk and accelerate the schedule. The decision was made. The Soviet shuttle would closely follow the American configuration. The same delta wing shape, the same cargo bay dimensions, the same heat shield approach. But there would be improvements. Soviet engineers identified weaknesses in the American design and corrected them. The copy would not be exact. In some ways, it would be better. The program was called Buran, Russian for snowstorm. Development began in 1976. The scale was enormous. Over 1,200 enterprises across the Soviet Union contributed components. More than 1 million people worked on the program at its peak. The orbiter itself was built at the Tushino machine building plant near Moscow. It looked almost identical to the American shuttle. The same shape, the same size, the same black and white thermal protection tiles. But look closer and differences appeared. The American shuttle's main engines were mounted on the orbiter. They fired during launch and returned to Earth with the vehicle, requiring extensive refurbishment between flights. Buran had no main engines. Its propulsion came from the Energia rocket, a separate heavy-lift vehicle. The engines stayed with the rocket and were discarded. This made the orbiter simpler and lighter. American shuttle required pilots for landing. Its flight control system was designed for manual operation with computer assistance. Buran was designed for fully automatic flight. It could launch, orbit, and land without any crew aboard. The computers handled everything. These improvements were not accidental. Soviet engineers had studied the American design, identified its compromises, and found better solutions. Buran needed a rocket. The Soviets built one of the most powerful ever created. Energia was a heavy-lift launch vehicle capable of putting over 100 tons into orbit. It was more powerful than the American shuttle's combined propulsion system. It was more powerful than the Saturn V that had sent astronauts to the moon. The rocket used 4 strap-on boosters and a central core stage. Each booster was powered by a 4-chamber RD-170 engine, the most powerful liquid-fuel rocket engine ever built. The core stage used 4 RD-0120 engines, burning liquid hydrogen and oxygen. Energia was not just for Buran. It was designed as a universal heavy-lift vehicle. It could launch the shuttle, or it could launch other massive payloads, military space stations, interplanetary probes, whatever the Soviet Union needed. The first Energia flew in May 1987, carrying an experimental military payload. The rocket performed perfectly. The payload failed, but that was a separate issue. The second Energia flight would carry Buran. November 15, 1988. Baikonur Cosmodrome. Buran sat on the launch pad, mounted on its Energia rocket. The weather was terrible. Strong winds, low clouds. Conditions that would have scrubbed an American shuttle launch. But Buran had no crew. The risk was only hardware. The decision was made to proceed. At 6 in the morning Moscow time, the engines ignited. Energia lifted off, carrying Buran toward orbit. 8 minutes later, the shuttle separated from the spent rocket and entered space. For the next 206 minutes, Buran orbited the Earth twice. The flight control computers managed attitude, monitored systems, and prepared for re-entry. Then came the moment of truth: re-entry and landing. Buran hit the atmosphere at 25 times the speed of sound. The heat shield protected the vehicle as temperatures reached 1,500 degrees. The computers adjusted the trajectory, managing the descent with precision no human pilot could match. As Buran approached the runway at Baikonur, conditions were challenging. Crosswinds gusted to nearly 20 meters per second. Visibility was limited. Any human pilot would have been stressed. The computers were not stressed. They calculated, adjusted, and executed. Buran touched down on the runway centerline. The deviation was 3 meters. It rolled to a stop exactly where planned. The first fully automatic spaceship landing in history. No pilot, no remote control. Just software doing what it was designed to do. The flight was a stunning achievement. Buran had demonstrated capabilities the American Shuttle did not possess. Fully automatic flight from launch to landing. The ability to operate in conditions that would have prevented manned missions. A more flexible architecture with the separate Energia rocket. Soviet engineers celebrated. After years of work, they had not just matched the Americans. In some ways, they had exceeded them. Plans were made for the future. More Buran orbiters would be built. Regular flights would begin. A space station called Mir 2 would be serviced by the shuttle fleet. The program had a bright future. Then the Soviet Union collapsed. In December 1991, the red flag came down over the Kremlin. The Soviet Union ceased to exist. Russia inherited its space program, but not its resources. The new Russian government faced economic crisis. There was no money for space shuttle flights. There was barely money to keep the lights on. Buran was grounded. The program was suspended then, canceled. The orbiters were put in storage. The spacecraft that had demonstrated such remarkable capabilities would never fly again. The final chapter was written in 2002. Buran and an Energia rocket had been stored in a hangar at Baikonur. The facility was aging. Maintenance had been deferred for years. No one had money to fix the roof. On May 12, 2002, the roof collapsed. 8 workers were killed. The debris fell directly on Buran and the rocket. The spacecraft that had made history was crushed under tons of concrete and steel. What remained was unrecognizable. The most advanced Soviet spacecraft ever built, reduced to scrap metal. The thermal protection tiles that had survived re-entry temperatures could not survive a falling roof. There was nothing to salvage, nothing to restore. Buran was gone. Other orbiters existed. Petichka, a second flight-ready shuttle, remained in storage at Baikonur. Several test articles were scattered across Russia and Kazakhstan, but none would ever fly. The hangar collapse was a fitting end to the program. Not a glorious retirement, not a museum display, just decay, neglect, and disaster. Buran's single flight left questions that will never be answered. If the Soviet Union had survived, what would Buran have become? The program had ambitious plans, regular flights to space stations, military missions, perhaps even flights beyond Earth orbit using the powerful Energia rocket. Could Buran have been safer than the American Shuttle? The automatic landing system eliminated pilot error. The separate engines eliminated some failure modes that plagued the American design. The Challenger and Columbia disasters might not have happened with a Buran-style architecture. Could Buran have been more capable? The Energia rocket could lift more than the shuttle's propulsion system. Buran could have carried heavier payloads, reached higher orbits, accomplished missions the American Shuttle could not. We will never know. History gave Buran one flight and then took everything away. The irony is bitter. The Soviets stole American technology to build their shuttle. They improved upon it. They demonstrated capabilities the Americans lacked. And then their creation was destroyed, not by American competition, but by Soviet collapse. What remains of Buran? Patichka still exists, slowly deteriorating in a hangar at Baikonur. Kazakhstan has discussed restoring it for museum display, but nothing has happened. Time and neglect continue their work. Test articles are scattered across the former Soviet Union. One is displayed in a Moscow park. Another is a tourist attraction in Germany. Pieces of the program have become curiosities rather than engineering achievements. The technology lives on in different ways. The RD-170 engine developed for Energia became the basis for the RD-180, which powers American Atlas V rockets. Soviet engineering, developed to copy American spacecraft, now launches American satellites. The lessons of Buran are remembered by engineers. Fully automatic landing is now standard for spacecraft. Reusable vehicles are returning with SpaceX and others. The ideas Buran demonstrated are part of the foundation of modern spaceflight. But Buran itself is gone. A single flight, a hangar collapse, and endless questions about what might have been. The space shuttle that the Soviets stole became a symbol of Cold War competition. Two superpowers racing to dominate space. One built first, one built better. And then both programs ended, not with triumph, but with disaster. The American Shuttle flew for 30 years and 135 missions before retirement. 14 astronauts died in 2 accidents. The program achieved great things and paid terrible prices. Buran flew once perfectly and then died in a collapsing building. No cosmonauts were lost because no cosmonauts ever flew. The program achieved one remarkable success and then vanished. 2 shuttles, 2 stories. One built on American innovation. One built on stolen secrets. Both ended by the weight of history and the limits of ambition. That is the legacy of Buran, the shuttle that flew once. The shuttle that proved the Soviets could match and exceed American technology. The shuttle that was destroyed not by failure, but by the collapse of the empire that built it. A snowstorm that came and went, leaving only traces in the frozen ground.